is Mr. Newman, and this is called Compound Inequalities 1 Intersections Notes. Tomorrow we will do Compound Inequalities 2 Union Notes, but this is just on intersections. So before we start, we got to introduce what a compound inequality is. So a compound is anything that has two or more of something. So a compound in science and chemistry would be when you're taking two or more chemicals and you actually combine them together to form a new substance. You could also have a compound sentence in English. This is actually a little bit closer to the way we're going to be using compound. So in English, a compound sentence is a sentence that has two ideas that are linked together by an and or an or. A compound word would be a word that has two words that are combined together. And then because it's an inequality, it's obviously going to be a less than or greater than or a less than or equal to or a greater than or equal to. So any compound inequality are two inequality statements which are connected by an and or an or. The first type, the intersection, that's the one we're going to talk about today, is a compound inequality connected by the word and. That and is very important. Its solution set contains only numbers that satisfy, and this is key, both inequalities or belong to both solution sets. So in other words, in a compound inequality that is an intersection, your solution or your solutions will satisfy both of the inequalities. So for the example, right, here's a compound inequality, an intersection, where x is greater than -1, and that keyword and, x is also less than 5. So how would I graph that? Well, if I went the long way, I could graph the first inequality in blue. So x is greater than -1, so here's -1. Oops. There's -1, and so I would do my open circle, and I would now shade my line that way. I did a little breakdown, but I'll show you why in a minute. And then I could do my second inequality in red. Here's 5. Again, an open circle, and this time it's less than, so it's going to go this way. Right, now it's shade all the way that way. And you can see if there's a part where they intersect, they overlap, and there are parts that they don't. So if I were to actually show the intersection, I actually wouldn't want the parts where they don't overlap. And so my solution would be actually this whole section here between these 2 points. And so what I would do, now working a combination of red and blue would be purple, I would shade between those two open circles. So only numbers that are both greater than -1 and less than 5 satisfy this compound inequality. An intersection can be thought of where the two inequalities, and I'd like you to write the word, overlap. Okay? Another way to express intersections, since the value of x is actually between -1 and 5, you can write it as a compound inequality. That's actually another way to write it. Compound inequality, you read that as -1 is less than x is less than 5. This can be read as x is greater than -1 and also less than 5. So that would be a different way of saying it. Or x is between -1 and 5. And here, notice this word here, not inclusive. That means there's no equals. X can't be equal to -1 and x can't be equal to 5. And we know that because these are open circles. If they were closed in, filled in, if it was -1 is less than or equal to x is less than or equal to 5, then we would say inclusive in this sentence. But since this is not inclusive, we say not inclusive. So those are key words. The other thing you're going to need to know for your homework is that sometimes we use this fancy Greek symbol. It looks like an upside down U, and that is red intersection.